Okay, it's time to learn another way to solve quadratics. We already know how to solve using the factoring method, and now we're going to talk about how to solve using square roots. So first, let's just talk a little bit about squaring numbers and square roots. So I want you guys to pause this video and think about the next questions that are on this at the top here. How many numbers can be squared to get 9? Or in other words, how many solutions are there to the equation x squared equals 9? And then what are those answers? Okay, so press pause and then come back and keep watching this video. So when we think about numbers we square to get 9, probably the first one that came to your mind was 3. Because if I do 3 squared, I get 9. Now if you think about this enough, hopefully you'll come up with one other answer. If you square -3, you're also going to get 9. Because -3 times -3 is going to give you 9. Okay, so that means that if I say x squared equals 9, the two x values that work here are x equals 3 and x equals -3. Okay, so one way that we can solve this equation, x squared equals 9, if we didn't maybe know the answers to this one right off the bat, is we can think about undoing the square root by undoing the square by taking the square root. Okay, so a squared exponent, so 2 exponent and a square root, are inverses of each other. They undo each other. So if I take the square root of both sides, then I'm going to get x equals the square root of 9. But I need to add one thing. I need to add this special new symbol, which is a plus and a minus sign combined. And that means that when I take the square root, I need both the positive version of the square root of 9 and the negative version of the square root of 9. So if I know the square root of 9 is 3, then I know my answer is positive or negative 3. If I wanted to translate that into like numbers without those weird symbols, I would have that x equals a positive 3 and x equals a negative 3. So I'm getting those same two answers. Okay. So let's do that same thing over here with x squared equals -9. Now this one's a little bit trickier maybe to think about because it's harder to think about two numbers that multiply together to give you a negative number. So let's solve this using our square root property that we just thought about. I'm going to take the square root of both sides. So on the right side, the square and the square root cancel each other out. So I just have x equals the positive or negative square root of -9. Now, we recently learned how to take square roots of negative numbers, and we take square roots of negative numbers by introducing the imaginary number I. Remember? This is the same thing as x equals positive or negative I square roots of 9. The square root of 9 is still 3, so I have a positive or negative 3i. Which means if I were to kind of separate this out, I would get x equals a positive 3i and x equals a negative 3i. Okay, and those would be the two solutions to my problem. So this is just one thing to look at. When you're taking square roots, notice that I got two answers every time, right? I got a positive answer and a negative answer. So you're going to see that kind of pattern throughout the rest of this section. So this square root property that we're going to talk about next, we've actually already kind of seen it. So the square root property is that the square root undoes a square, right? Or an exponent of 2. Okay? And inverses are what we just talked about. Inverse operations undo each other. So like a squared exponent and a square root, those undo each other. Okay, so that's why like x squared, the square root is equal to x. Okay. So we're going to use this information about what we know about square roots and squares to solve quadratic equations by taking square roots. So you can't always use this method, but you want to do this when the equation has a perfect square in it and no other variables. So you're going to see some examples of that in just a second. I'm actually going to work through the steps of this equation, of this process, using example A down here. Okay. So if I want to solve x squared equals 50, my first step is to isolate the perfect square on one side of the equation. So when I say isolate, I mean get it all by itself. So right here I have the x squared, which is the perfect square, and it's all by itself on one side of the equation. So I've already done step 1. My next step is to take the square root of both sides. Okay, and I can't forget to have a plus and minus sign. So then x equals a positive or negative square root of 50. Okay. My next step is to simplify the square root. So I'm just going to come over here on the side, do a little scratch work over here, and simplify the square root. And you want to always show your work for these, so don't just skip this part. So when I'm simplifying square roots, I'm just looking to break down the number and then look for pairs of numbers. So I have a pair of 5s with a leftover 2, which means I can rewrite square root of 50 as 5 square roots of 2. So I'm going to come back to my problem over here, and I'm going to replace the square root of 50. Oops. Sorry, I forgot to write x. X equals positive or negative. The square root of 50 is now 5 square roots of 2. Okay. So right now I'm going to separate this into my two answers. X equals 5 square roots of 2, and x equals negative 5 square roots of 2. My final step is to isolate the variable, which means get that x by itself. And luckily with this problem, I already have the x by itself. So that one is going to be done, and those are the two answers. Okay, let's work through the next example. So with b, my first step, if I remember, is to isolate the perfect square on one side of the equation. So I have 2z squared equals negative 48. So I'm going to start by getting that z squared by itself by dividing both sides by 2. Then I'll have z squared equals negative 24. Okay. My next step is to take the square root of both sides. And I'm not going to forget that I have a positive and a negative, a plus minus sign. So then I have z equals positive or negative square root of negative 24. Then I'm going to come over here again and simplify the square root of negative 24. Whenever I see a negative inside, my first step is to introduce I and make it positive. Then I'll just start breaking apart 24 and looking for pairs of numbers. And once I have it broken down, I have a pair of 2s, and then a leftover 2 and a leftover 3. So the pair of 2s goes outside my square root, and then I multiply the 2 and the 3 together and put that inside my square root. Then I'm just going to come over here and replace the square root of negative 24 with 2. Ooh, I forgot something over here. I forgot my I. It's really easy to forget that I, but don't forget to carry it down. So it should be 2I square roots of 6. Okay? And so my two answers are going to be z equals positive 2I square roots of 6 and z equals negative 2I square roots of 6. Okay? All right, we're ready for some more advanced examples. So let's do C. This one looks simple, but it doesn't have an extra step for us. So in this case, I have a set of parentheses. I have a y plus 1 squared. So my first step I know when I'm solving using square roots is to get the square or the perfect square by itself on one side of the equation. And I already have that done. The y plus 1 squared, that's the perfect square, and it's already on the right side of the equation. Okay, so I'm going to move to the second step, which is to take the square root. Okay, so this square root is going to cancel out this exponent right here, and I'll have the positive or negative square root of 16 equals y plus 1. Okay, I'm going to simplify the positive or negative square root of 16 to positive or negative 4 equals y plus 1. And at this point, my next step is to get the y by itself. What I'm going to do before I do that is I'm going to separate this into positive 4 equals y plus 1 and negative 4 equals y plus 1. It's really important that you do this step because it might mess up. If you don't do this step, then you're going to probably mess up and make a mistake in the next place. So what I'm going to do is I'm just going to solve each equation. So negative 1, negative 1. So 3 equals y. That's one of my answers. And then my other answer is negative 5 equals y. And if you want to rewrite that so that the y comes first and it's y equals negative 5, that's fine. But this is perfectly acceptable. Okay. So an important key to this step of the process is that you've got to break up the positive or negative 4 pretty much right when it shows up. Okay, you want to do that before you subtract the 1 from both sides of the problem. Okay, let's jump down. Let's do an even more complicated one. Let's do one like h. Okay, kind of got a lot going on in h. So my first step is to isolate the perfect square. So I'm just going to draw a little green box around the perfect square so that we can see it. So whatever the piece of your equation is that's being squared, that's what you're trying to get by itself. Okay, so you're trying to get that green square all by itself. So I'm going to start by subtracting this 6 from both sides. So I have negative 4 times w plus 3 squared equals 80. Then I'm going to divide by negative 4 to cancel out the negative 4. So then I have w plus 3 squared equals negative 20. I'm going to zoom up on this problem just because I feel like I'm writing kind of small. Okay, so I now have the perfect square isolated and by itself. So now I'll take the square root of both sides. So then I have w plus 3 equals the positive or negative square root of negative 20. Okay, so I'm going to come and do my scratch work over here. Square root of negative 20. First thing I do is get the I in there. And then I start breaking apart the 20. I have a pair of 2's and a leftover 5. So this turns into 2i square roots of 5. And if you're having a hard time simplifying these square roots, you're probably going to want to go back and watch some videos about simplifying square roots. That's from Unit 3, I believe. So I'm going to come back over here, and I am going to replace the square root of negative 20 with 2i square roots of 5. Okay. Now my next step is to separate this into w plus 3 equals positive 2i square roots of 5, and w plus 3 equals negative 2i square roots of 5. And then I'll subtract, and I'm going to just isolate the w. So I'm going to subtract 3 from both sides to get that w equals 2i square roots of 5 minus 3. So that's one of my answers. And I'll do the same thing over here. I'll get w equals negative 2i square roots of 5 minus 3. Okay? So those are my two answers. This answer in h is pretty complicated, right? I've got an I and I've got a square root. So make sure you're careful and that you keep track of all of your signs and everything that you're working on. Okay. I've got time to do one more example for us. So let's do one with a fraction. Let's go ahead and do, not that one. Actually, sure, why not? We'll do 16. Okay, I'm going to start by getting rid of this. I've got to get the perfect square by itself. So again, this perfect square is the thing that I've put in a green box. So I first have to get rid of that negative 1/3 fraction. And there's a couple different ways of thinking about it. What I like to do is think about if I multiply this side of the equation by negative 3, the negatives will cancel out and then the 3's will cancel out. So I'm just going to multiply both sides of the equation by negative 3. So 16 times negative 3 is negative 48. Sorry, this I wrote really poorly. This should be times negative 3. So negative 48 equals x minus 2 squared. Okay, I've got my perfect square isolated, so I'll take the square root of both sides. So I have x minus 2 equals, and then I've got to simplify the square root of negative 48. Okay, so that's I square roots of 48. Then I'll just start breaking that down. So I've got, let's see, 6 and 8, 2 and 3, 4 and 2, 2 and 2. Okay, so I have one pair of 2's, two pair of 2's, and then a leftover 3. So the two 2's will multiply together and go outside my square root along with that I pulled out at the beginning. Then I have a square root of 3 left on the inside. Okay, so let's come back over to my problem, and I'm going to replace the square root of 48 with positive or negative 4i square roots of 3. Okay. Then I'll separate this into 4i square roots of 3 equals x minus 2, and negative 4i square roots of 3 equals x plus minus 2. Then your final step would be to add 2 to both sides of the equation.